press the bell icon on the YouTube app and never miss another update.
So, hello students. In the last class we discussed about the some questions with reference to the hydrogen. Let us continue the concept. The next question is, so here the compound CH3 CmgCl on reaction with heavy water produces the following. Okay, so here you know that this CH3 thrice CmgCl is nothing but a Grignard reagent. What it is? It is a Grignard reagent. You are going to learn in higher classes about this reagent, which is very useful in the preparation of many of the organic compounds. Grignard reagent, which is generally represented by the formula RMgX, where this R group is nothing but an alkyl group, and then Mg is nothing but the metal, and this X is nothing but any of the halogen. This is of the form RMgX. So this on reacting with our heavy water, that is nothing but D2O. So what it will form? So this reaction also you learn in case of preparations of alkanes. So the product will be for this one, that is if you write the reaction, CH3 thrice C MgCl plus heavy water if you take, that is nothing but D2O, it will form into the first one, that is nothing but CH3 thrice, right? CH3 thrice CD with the formation of Mg, the formation of OD, what is the halogen here? Cl. So what is the answer for the question? That is nothing but option A, CH3 thrice CD, that is nothing but an alkane. Okay, so in place of this one, if you take D, that is H, means that will become propane. Okay, so that is butane, that is the compound you are going to get when you react this what is that Grignard reagent with the heavy water. This is the product what you are going to get. Whatever it may be the Grignard reagent, no, you are going to get this one as a byproduct. Just there is a displacement or replacement of, you just see here, this help in the hydrolysis, D2O, right? So here there is the addition of what hydrogen to this carbon, and then remaining will be MgOHX. Generally in this example it is MgODCl. You have to remember this one. Okay, this is common. So in second phase it is very important reaction again. Okay, if you move on to the next question. Hydrogen molecule differ from chlorine molecules in the following respect. So that is the first one, hydrogen molecule is non-polar but chlorine is polar. Hydrogen molecule is polar while chlorine molecule is non-polar. Hydrogen molecule can form intermolecular hydrogen bonding but chlorine molecule does not. Hydrogen molecule cannot participate in coordination bond formation but chlorine molecule can. So how it differ means, so all remaining three are similar to, they are correct, but the last option, hydrogen molecule cannot participate in coordination bond but chlorine molecule can, that is the answer for this question. Why? Because you know that if you write the hydrogen molecule structure, you can see that hydrogen atom, each hydrogen atom contribute one electron, results in the formation of a hydrogen molecule. There will be no free electrons here. But if you take the chlorine, so if you write the chlorine, its atomic number is 17. In the valence orbital there are 7 electrons from one chlorine atom and 7 electrons from one more chlorine atom. So if they are involved in the formation of a bond, so then you can see that there is a presence of 3 pairs of lone pairs of electrons. Because of the availability of lone pair of electron, it can form what? Coordination bond, whereas hydrogen will not form the coordination bond. So that is the option 4 is the answer for this question. If you move on to the next one. The next question. Okay, which one of the following property has same value for H2 and D2? Okay, you know that H2 and D2 both are what? That is either it is density or bond dissociation enthalpy, bond length or melting point. As you know that this hydrogen and deuterium, they are nothing but isotopes. So isotopes means they are having same value for the bond length. Same value for bond length because they are isotope. Remaining properties they are different but chemically they are same. This bond length is nothing but a chemical property, whereas your density, melting point, all they are the physical properties. As they are isotopes, they are having the same bond length. Simple concept that is. So move on to the next question. That is it is a calculation. The volume strength of 3 normal H2O2 solution is. So in the beginning of the discussion itself, I have given some formulae that is with reference to the that is normality and volume strength, molarity and volume strength. This question is on the basis of the relationship between normality and volume strength. How they are related to one another? So you know that volume strength is equal to 5.6 into normality. So the question is they given 3 normal, what is that? H2O2 solution. What is the volume strength of 3 normal H2O2? Very simple question. Just rearrange this one. They have given the normality. You have to calculate volume strength. That is equal to 5.6 into 3. Okay. So 3 6 are 18, 1 carry, 5 3 are 15 plus 1 16. 16.8, yes it is there, yes. The option 4 is the answer. The answer for that question is fourth one, 16.8. So this is how you can calculate the volume strength if they given the normality by using this expression. Yes. Move on to the next question. Yes. Which reaction shows oxidizing nature of H2O2? So you can observe here, so many reactions were given. Out of these reactions, which reaction shows oxidizing nature of H2O2? I think I explained while explaining the oxidizing and reducing nature of this H2O2. Whenever you explain about oxidizing nature of H2O2 means in the product you should get what? Water. It will be get oxidized to water. If you are explaining about the reducing nature, it will be reduced to O2. It will be reduced to O2. Okay. While telling oxidizing nature, you should see that it should convert it into water. While explaining the reducing nature, it should be O2. Okay. So if you observe the reaction, you can see that question, the option number 2, 3, 4, all are having the product O2. That is H2O2 has been converted into O2. All this shows what? Reducing nature of what? Written here, reducing nature of hydrogen peroxide. The question is with reference to the oxidizing nature. So the first one, that is H2O2 plus 2Ki gives rise to 2KOH plus I2 is the answer for this question. Okay. So there is a formation of iodine. Potassium iodide has been reduced to iodine. Sorry, has been oxidized to iodine, because you can see that minus 1 to 0, Ki is plus, Ki is minus 1, I2 is 0. There is an oxidation of this potassium iodide to iodine, because the removal of positive element is also the oxidation. Okay, so that is. So if you move on to the next question. Okay, aluminium reacts with caustic soda to form aluminium hydroxide, aluminium oxide, sodium meta-aluminate, sodium tetra-aluminate. So the answer for this question is sodium meta-aluminate. If you want the reaction, just I will write whenever aluminium react with, what is that? That is sodium hydroxide, aqueous solution of sodium hydroxide. So it will form into 2NaAlO2, that is sodium meta-aluminate with the liberation of dihydrogen gas. This is the product. What do you call for this one? This is called as sodium meta-aluminate. Okay, so that is. So if you move on to the next one. Next question is with reference to the that is nothing but the physical properties, that is the correct order regarding the covalent nature of hydrides is, the correct order regarding the covalent nature of hydrides is. So many options are there, just go through those. So the answer is the first option, because you know that. So here the covalent nature means it is dependent on the size. As you go down the group, it is all our second group element. So that is beryllium, magnesium, calcium, strontium, barium. That is the order, right? If you go down, what happens? There is an increase in the size. So the option 1 is the answer for that one. That is beryllium, then magnesium, then you are having calcium, then you are having barium, then you are having the strontium. Okay, sorry, this is strontium, the last one is the barium. If you observe in the down the group, what happens? What atomic size increases? As the atomic size increases, covalent nature decreases. They ask you here the correct order of covalent nature of hydrides. So which is the having highest covalent character? Beryllium, then magnesium, then calcium, then strontium, finally the barium, right? As the size increases, covalent nature decreases, ionic nature increases. Because of that, so the answer for this one is the first one, that is beryllium hydride greater than magnesium hydride greater than calcium, then barium, strontium, finally the barium. So this is how. Then the next question. Yes, this is with related to physical properties. Which of the following atomic and physical properties of hydrogen is false? Which of the following atomic and physical properties of hydrogen is false? If you go through the all the what is that options, so option 2, 3 and 4 are correct with reference to their density, boiling point and relative abundance. But if you take the first one, it is actually, it should be in the order, that is hydrogen greater than deuterium greater than tritium. That is the correct, because if you take here, which of the atomic following is physical property is false, they ask, right? So actually option 1 is false, because it should be in the order H2 less than D2 less than T2, right? So this is the correct answer, because melting point, if you observe the melting point, which is having the highest melting point here, T2. Tritium is having the highest melting point, then D2, least is nothing but H2, because you know the mass number, atomic mass number. So it is 1H1, 1H2 and this is 1H3. Higher the mass, higher will be the melting point. That is the clue. So this is the correct order, but option 1 is wrong order. Remaining all are correct. So answer for this one is the option 1. Okay. So if you move on to the next one. Yes, the property of hydrogen which distinguishes it from alkali metal is its electropositive character, affinity for non-metals, reducing character, non-metallic character. So we discussed this one also. So that is, if you take the alkali metals and compare with the hydrogens, so first 3 properties they are correct, but the last one, there is a non-metallic character. You know that alkali metals are metallic in nature, hydrogen is non-metallic in nature. That is the 4th option which distinguishes it from the alkali metals. Okay. So option 4 is the answer for that one. If you move on to the next one. Which of the following statement is correct or incorrect with reference to the hydrogen? I read once again. Which of the following statement about hydrogen is incorrect? So dihydrogen does not act as reducing agent. Hydrogen has 3 isotopes, which out of which protium is the most common. Hydrogen never acts as cation in ionic salts. Hydronium ion exists freely in solutions. Okay, so the answer for that one is nothing but the first one. Hydrogen does not act as reducing agent. You know that hydrogen is a very good reducing agent. Hydrogen is a good reducing agent. Okay, so you can learn this one with the help of a simple reaction. If you take cupric oxide, if you made to react with the dihydrogen, so it reduces cupric oxide to copper with the formation of a water molecule. With the formation of a water molecule. So likewise you can have one more reaction also, that is ferric oxide. If you take, that is used in case of the blast furnace, there also ferric oxide has been reduced to what? Iron. So all those properties show that it is a very good reducing agent, but they have given here it does not act as a reducing agent. That is the incorrect statement. If you move on to the next one. So here there is a match the following like type question. So they given a list 1 and list 2, hardness of water, temporary hardness, Kalgan, permitted. You have to match with the list 2. Okay, so you know that hardness of water is mainly because of what? The dissolved salts of bicarbonate, chlorides and sulfate. Okay, that is the option, first option will be 3A3. Okay, and then if you move on to the temporary hardness, that can be removed by simple boiling, that will be B for B, it is 1, where it is A3 B1. Okay, next Colgan is nothing but sodium hexametaphosphate, that is 5 C5, and D is nothing but the permutate, that is sodium aluminium silicate, hydrated sodium aluminium silicate, that is the 4th, where we can see this one. So that is nothing but second one. Option 2 is the answer for this one. There we can see A for A3, B1, C5 and D4. Okay. So if you move on to the next. Okay. Alkali metal hydrides and treatment with water gives. So answer for that one is nothing but hydrogen. You can understood with the help of a simple example. If you take potassium hydride, and if you made to react with water, that is nothing but H2O, what it will form? It will form potassium hydroxide, KOH, and there is a liberation of what? Dihydrogen. So that is the concept. Whatever it may be the alkali metal hydride you take, the following reaction will take place. Okay, so that is 4th option. Next question. Yes, ordinary hydrogen at room temperature is a mixture of. So many options has been given. Out of those, the correct answer, I have given this information in the notes. 75% of orthohydrogen and 25% of parahydrogen. Temperature is ordinary temperature, that's why this ratio. This may be asked in terms of ratio also. At ordinary temperature, the ratio will be like that. The question also come. Then you have to remember it is 3:1. 3 is nothing but ortho, and then 25, or you can say 1% is nothing but the para. That is option number 1. Next. Next question. Solubility of sodium chloride in heavy water is same as that in water, 15% lower than that in water, 15% more than that in water, 100% more than that in water. So the answer for this one is nothing but the second option, that is 15% lower than that of the water, because you know the reason for that one once again, because of its lesser value for dielectric constant. The solubility of compound depends on the dielectric constant of that particular solvent. So here heavy water is having the lesser what dielectric constant than the water, so its solubility is lesser than in case of the water. So the option B, or you can say 2 is the answer for this one. We move on to the next one. Yes. On shaking H2O2 with acidified potassium dichromate and ether as a solvent, ethereal layer becomes. So this is on the oxidizing nature of this hydrogen peroxide. It oxidizes potassium dichromate to chromate, CrO5, in the presence of the solvent ether. So then you are going to get a color that is nothing but blue color. Okay, that is mainly because of the formation of a compound, that is CrO5. It is what? Blue in color. So that's why you can take this one as a test for or to know the oxidizing nature of hydrogen peroxide by change in the color. Okay, so that is next. Yes, out of the following metals, which will give hydrogen on reaction with sodium hydroxide, whether it is zinc, magnesium, aluminum or beryllium. So the answer for this one is the second option, that is 1, 3 and 4. 1, 3, 4. So what is 1 here? That is nothing but zinc, 3 is aluminum and 4 is beryllium. So because all these three are amphoteric in nature. These are amphoteric in nature, that's why they will react with the metal, that is hydroxide NaOH, to give the hydrogen gas. So you can take simply NaOH plus zinc, no? So it will form the zincate with the formation of the dihydrogen, that is. So next one. Next question. Yes, which pair are not isotopes? Okay, so the ortho and para hydrogen, they are not isotopes. Protium and deuterium isotopes, deuterium tritium isotopes, tritium protium isotopes. They ask which are not isotopes. Option 1 is the answer. So that is ortho and para hydrogens are not isotopes. So if you move on to the next one. Next question. Okay. Ionic hydrides are usually good electrical conductors when present as solid, easily reduce, good reducing agent, liquids at room temperature. Okay. So they are good reducing agents. That is the direct answer. So good reducing agents. But first one is wrong because they are not electrical conductors in the solid state. They are not easily reduced. They will reduce others. And they are solids at room temperature. Next one. Yes. Among lithium hydride, sodium hydride, potassium hydride, rubidium hydride, cesium hydride, the correct order of increasing ionic character. As I already explained, in the last question they asked about the covalent nature. Here they ask about the what? Ionic nature. So what is the order of that one? So as the size increases, ionic character increases. So the answer for this one, or you can say the order for this one, is nothing but the second option. So what is that? Lithium hydride less than sodium hydride less than potassium hydride less than rubidium hydride less than cesium hydride. This is the correct order of what? Increasing ionic character. Increasing means from lesser to the higher, which is highly ionic in nature, cesium hydride. So that is the concept. Next question. Okay. Which of the following is correct for hydrogen? Which of the following is correct for hydrogen? It can form compounds in +1 as well as -1 state, +1 and -1 state, and then it always collected at cathode. It has very low ionization potential. It has same electronegativity as halogens. So these 2, 3 and 4 are wrong. The first one is the correct. Because it can form both +1 and -1, +1 and -1 oxidation state. +1 in case of other elements, okay, and -1 in case of hydrides. So while discussing the oxidation number, you are going to get hydrogen exhibit a oxidation number of -1 in case of where hydrides. So next question. Yes, correct statement from the following. They have given some set of reactions. Mixture of CO plus H2 is syngas. Yes, it is correct. Then C solid plus H2O gives rise to CO plus H2. This process is called coal gasification, right? Metals of 7th, 8th and 9th group do not form hydrides. So what we call that one? That is called as hydride gap. Then all of these. Yes, answer is all of these. Okay, next. Next question. Yes, protonic acid is a compound that forms solvated hydrogen ion in polar solvent, an acid which accepts a proton, a compound that forms hydride in polar solvent, an acid which cannot donate a proton. Okay, so the simple concept this is, so answer for this one is nothing but the first one, because whenever this hydrochloric acid or any acid, if you dissolve in water, it will form the hydronium ion. Right? You can have the example of HCl plus H2O, it will form into H3O plus, right? Plus what you can have Cl minus, plus Cl minus. So this is the concept. You can see this one is nothing but the solvated ion. Okay, so the first one. Next question. Yes, that is separation of H2O and D2O by fractional distillation is possible because D2O has higher density than that of H2O, higher boiling point than that of the water. Deuterium oxide has higher freezing point, lower dielectric constant than that of. So the second option, higher boiling point than that of water. You know, fractional distillation means, so it is basis for that one is, what is that? It is a separation of compound, fractional distillation. Separation of compounds or solvents from one another based on their boiling points. And the difference between the boiling point should be low. Very low difference should be there. Then only they can be separated from one another. But here the heavy water, or you can say heavy water is having higher boiling point than that of water. Okay, that's why it cannot be separated by this fractional distillation. Next question. Okay, the hydride having highest electrical conductance. So lithium hydride, beryllium hydride, calcium hydride and titanium hydride. Answer is direct titanium hydride, because you know that titanium hydride is a metallic hydride. Is a metallic hydride, is a very good conductor. Okay, that's one. Next question. Yes, an element reacts with hydrogen to form a compound A, which on treatment with water liberates hydrogen. The element can be nitrogen, chlorine, selenium, calcium. So it is actually calcium, because you write calcium react with hydrogen to form what? Calcium hydride, that is the element A, which upon reaction with water, what it will form? It will form calcium, and with the liberation of what? That is nothing but the hydrogen gas at anode. This is based on their electrolysis, right? So that is this is nothing but calcium hydroxide actually, CaOH twice plus hydrogen. This is the actual reaction which takes place. So the answer is option 4, calcium. Next question. Yes, simple calculation. The number of moles of H2O2 needed to reduce 1 mole of KMnO4 in acidic medium. Okay, first let us write the reaction for this one. KMnO4, that is potassium permanganate. Okay, so on reaction with this hydrogen peroxide in acidic medium means sulfuric acid. Okay, so KMnO4 is reduced to K2SO4 plus it will form MnSO4. I will write here MnSO4 plus you can have 8 moles of water and 5 moles of oxygen. 5 moles of oxygen. The number of moles of H2O2 needed to reduce. That means to say it is acting as what? Reducing agent. It is reducing KMnO4 to what? MnSO4. Permanganate has been converted into manganate, MnSO4. Okay, so here what you have to calculate, how many moles of H2O2 are required. By looking at the reaction, you can see that, so for 2 moles of KMnO4, how many moles of hydrogen peroxides are required? 5 moles of hydrogen peroxide are required. Okay, so they ask you here for 1 mole. How many hydrogen peroxide are required for 1 mole? Simple. That is equal to 5 into 1 divided by 2. That will come around 2.5. Is there? Yes, it is there. So option B or 2 is the answer for that one. 2.5 moles. Okay, understood this one? This is a simple question. Again, next move on to the next question. This reaction is there in the textbook, NCERT textbook. Next question. Okay, the decomposition of hydrogen peroxide can be slowed by the addition of small amount of acetamide. The latter act as detainer, stopper, promoter, inhibitor. So here it is slowing the decomposition of hydrogen peroxide. What is that reaction? Decomposition of hydrogen peroxide is 2H2O2 gives rise to, yes, 2H2O plus O2. So this reaction is slowed down by the addition of what? Acetamide. Acetamide. So it is decreasing the rate of reaction. That means to say it acts as what? Inhibitor. Inhibitor. Okay. Option 4 is the answer for this one. Move on to the next one. Yes. Sodium sulfate is soluble in water, but barium sulfate is insoluble. So you know that solubility of any of the compound depends on 2 factors. What are those? One is the lattice enthalpy, and one more is nothing but the hydration enthalpy. So remember these 2 concepts, they are very important. So there should be lesser lattice enthalpy and greater hydration enthalpy, then only the compound will be soluble in that. Okay, lesser lattice enthalpy, greater hydration enthalpy. Let us check the question. The hydration energy of sodium sulfate is more than its lattice enthalpy. That is correct. The lattice energy of barium sulfate is more than its hydration enthalpy. Yes. The lattice energy has no role to play. No, it is wrong. Both 1 and 2. So the answer is both 1 and 2 because I already written here. So it is, what is lattice enthalpy is inversely proportional to the solubility. Hydration enthalpy is directly proportional to the lattice enthalpy. Okay, that is solubility actually. Hydration enthalpy is directly proportional to the solubility. So answer is 4th one, both 1 and 2. Move on to the next one. Yes, the correct order of dielectric constant value. Okay, the correct order of dielectric constant value is the first one because so many times I told H2O greater than T2O greater than T2O. That is the order. That is H2O2. H2O2, which is having the highest dielectric constant. Okay, but if you look at the second example, deuterium is the last, deuterium oxide, and then in the third example, H2O less than, it is wrong actually. So the option 1 is the correct answer. So that is H2O greater than D2O greater than H2O. Remember these 2, these are very important. Always heavy water is having lesser dielectric constant than the water, normal water. Next question. Yes. What is the volume strength of 100 ml of aqueous H2O2 solution containing 3.4 gram of H2O2? The options are 5.6, 11.2, 22.4, 100 volume. Let us calculate this one. So you know that molarity is equal to weight of substance divided by, molarity is weight of substance divided by volume in liters, right? So what is weight they have given here? That is 3.4. Actually what is the molecular mass of this one hydrogen peroxide is 34, right? 34 into volume in liter means 1000 divided by 100. 1000 divided by 100. Okay, because it is actually in the expression it is volume in liter, but they have given 100 ml of aqueous solution. That's why this is how you can calculate. So if you do calculation and all, you are going to get 1 here. Okay, and you know that volume strength is equal to so what is that, molarity into 11.2. Molarity into 11.2. What you got? Molarity is 1, 11.2. So answer will be 11.2 volume, 11.2 V. That is option B. Okay. Yes. Had you note down? This is very important again. Relationship between that is the volume strength and the molarity. First you have to calculate the molarity. If they given the weight, so you know this 34 how it will came? H2O2. H2O2, right? It is 2. It is 32. It is 32. 2 plus 32. It will come around 34. But in the problem they have given 3.4 gram. That's why we have calculated this one. Given mass by molecular mass. It will give the weight of that. Okay. So next one. Okay. Maximum density of heavy water is at, so that is on the basis of physical property. Option 2 is the answer for that one. 11.6 degrees Celsius. Okay. If they ask in terms of kelvins, it will be 284.6 Kelvin. 284.6 Kelvin, or you can say what is that? 11.6 degrees Celsius. Okay. Option B. Next question. Yes, number of water molecules in mole salt. For that you should know the formula of molecular formula of mole salt. Just make a note of that one. That is FeSO4 NH4 twice SO4 ferrous ammonium sulfate. It is 6H2O. 6H2O. Okay, so how many water molecules are associated here? 6. So the answer for this one is option 2, 6. Next question. More salt, ferrous ammonium sulfate. Next one. Okay, the composition of tritium is, again very simple concept. This is tritium means 1H3. Okay, so how many protons are there? 1. How many electrons? 1. How many neutrons? 3 minus 2 is 1 again. So where is that? 1 proton, 1 electron and 1 neutron. That actually 3 minus 1 is 2, right? 1, 1, 2. 1, 1, 2. Yes, option 3 is the answer for that one. Okay, 1 electron, 1 proton and 1, 2 neutrons. So next question. Yes, the weight of hydrogen peroxide present in 200 ml of 15 volume H2O2 solution. Okay, so this is one more important question here. It is, you can calculate 123. Okay, so here 10 volume H2O2 solution for this one. 10 volume H2O2 is equal to 1.786 normal. 1.786 normal. How it is? You know this one. Volume strength is equal to normality into 5.6. Normality into 5.6. Okay, if you want to know the normality, so that is nothing but volume strength. What is volume strength? 10 volume means 10 divided by 5.6. How much you are going to get? 1.786 normal. Understood how I calculated this one? 10 volume is equal to 1.786 normal. So in the question what they have given? In the question they have given about the, what is that? 15 volume. How much for 15 volume? How much for, it is for 10 volume means how much for 15 volume? How to do that one? 15 into 1.786 divided by 10. Divided by 10, it is normal, right? So again here 15 into 1.786 divided by 10 is equal to, what is normality? Normality is equivalent that is the weight of solute divided by equivalent weight into volume in liters. So what about this weight by solute, that is weight by volume is nothing but volume strength divided by equivalent weight. Okay, so for that you can have weight divided by 17 because you have to calculate the weight into volume in liters means, so 1000 divided by how much, what is the volume they given, 200 ml. Okay, so if you simplify this one, or you can first you rearrange this one, therefore weight is equal to what, 15 into 1.786 into 17 into 200 divided by 10 into 1000 divided by 10 into 1000. So on simplification you are going to get 9.1 gram. This is the weight of that substance. Okay, so is there? Yes, it is option 3. Yes, again important, if you want you can note down, these are side work. So there is a relationship between volume strength and the normality, and how to calculate normality, weight of solute divided by equivalent weight into volume in liters. From this you can calculate, then substitute in place of this normality. This is the equivalent weight of hydrogen peroxide, H2O2 is 17. Okay, on simplification you are going to get 9.1. Next. Yes, the structure of H2O2 is option 2, because you know that it is just like half book open. Okay, if you just open the book you are going to get the structure, this one. So where we can see this peroxide linkage. Option 2 is the answer for this one. Move on to the next. Okay, the number of protons, electrons and neutrons respectively in a molecule of heavy water. It is again simple question. D2O, heavy water means D2O, D2O. Okay, so if you take this deuterium, it will be represented as 1H2, right? And oxygen is O. Atomic number of oxygen is 8, right? So in case of this, how many proton, neutron and electron are present? They ask, right? It is 8 proton, 8 electron and then 8 neutron, because it is 16. Again 16 minus 8 is 8 only. 16 minus 8 is 8 only. So here D2O, from 1 deuterium means 1 proton, 1 neutron, 1 electron. And then there are 2 deuterium atoms. That's why 2 plus 2 plus 2 plus 2. How much you are going to get? 10, 10, 10. So that is the answer for this one is option number 1, 10, 10, 10. So this is how you can calculate. So in the next class we are going to discuss the remaining question. Thereby we can end up the concept hydrogen. Thank you.